Okay, so we're going to take a look at section 6.2, the sum and difference formulas. So this section and the next section in the course have to do with a lot of different formulas. For purposes of the test, you're not going to have all of these formulas memorized. I will allow you to bring in, actually I will provide a sheet with these formulas on them and only these formulas, no other formulas for earlier on in the course. But I don't want anybody hyperventilating out there thinking, how am I ever going to remember all these things? You'll have to know how to use them, but I will provide these formulas for purposes of a test. So let's get started here. The first type of formulas that we're going to look at are sum and differences. So these are going to involve the addition and subtraction of, we're going to look first at cosine and sines. And here are the first four formulas we're going to look at. The cosine when we're adding two angles, the cosine when we're subtracting two angles, then the sine of something when we are adding two angles, and the sine when we are subtracting. So taking a quick look at these and looking at some of the patterns to help us become familiar with them, if not memorize them. When we're looking at the cosine of two angles that are being added, we can see it's the cosine of the first angle multiplied by the cosine of the second angle, and now there's a subtraction in between the product of the sine of these two angles. When we are looking at the cosine involving a subtraction between two angles, that's equal to the product, the multiplication of the cosines of those two angles, and now we're going to be adding with the sine of those two angles, or I should say the sines. When we're looking at the sine of the sum of two angles, A plus B, that's going to be equal to, now it changes up a little bit, it's the sine of the first times the cosine of the second, and then plus the cosine of the first times the sine of the second angle. And last but not least, when we're looking at the sine of the difference or subtracting two angles, that's equal to the sine of the first, the cosine of the second, just like the one above it, but now we are subtracting the cosine of the first, the sine of the second. So these sound like a mouthful, but actually you could see the patterns in them. It's a multiplication of either two cosine or a sine and a cosine function, and then an addition and subtraction of either two sines being multiplied together or the cosine and the sine. So why would we do something like this? Why do we bother to learn something like this? The first example here shows us why. We're looking for the cosine of 105 degrees. So let's imagine a world, heaven forbid, where we have no calculators, and so we want to find this cosine of 105, but this isn't any of the angles that we know. We can find the cosine of 30 degrees, 45 degrees, 60 degrees, or then the quadrantal angle, 0, 90, 180, 270, or 360. And this 105 isn't any of those. So what we want to look to do to see, can we break down this angle of 105 degrees into two angles that we do know? And yes, we can. If we think about this, 105 can be broken down into 60 and 45, and we do know the cosine and sines of both of those angles. So the cosine of 105 degrees can be written as the cosine of 60 degrees plus the cosine of 45 degrees. Now, in case any of you are wondering, could I have written 45 and 60? Yeah, you can. It doesn't make a difference, the order here, because it is addition. So here, our alpha, our first angle, is 60 degrees, and then our beta is 45 degrees. So we've identified our two angles. Now, when we go up here to our list, we can see we're going to be using this first formula here. So I'm going to write that down. That says the cosine of adding alpha and beta is equal to the cosine of alpha times the cosine of beta, now minus the sine of alpha times the sine of beta. So when we want to use this formula, we can see we're going to need certain information, namely the cosine and sine of both of these angles. So I'm going to come up here and let's take a look at that. So we have 60 degrees. So we need the cosine of 60 degrees, and then we're also going to need the sine of 60 degrees. And we're going to need the cosine of 45 degrees, and we're going to need the sine of 45 degrees. So we're going to need these four pieces of information. So the cosine of 60 degrees is 1 over 2, 1/2. The sine of 60 degrees is radical 3 over 2. And then over here, the sine of 45 degrees is radical 2 over 2. And the sine of 45 degrees is also radical 2 over 2. So we have the four sine and cosine information that we need. So now we can come back here into our formula and start to do our substitution. So being that this is the first one we're going through, let me write exactly what we're doing here so you can follow as you take your notes. So we have said that alpha is 60 degrees. So we're going to be looking at the cosine of 60 degrees. We said beta is 45. So we're looking at the cosine of 45 degrees. Now our subtraction from our formula. The sine, since alpha is 60, we're going to look at the sine of 60 degrees. And then the sine beta is 45, the sine of 45 degrees. So here's the general form of the formula, and here I've substituted in our specific angles for this example. Now we can go and substitute in these values here. So we said that the cosine of 60 is 1/2, cosine of 45 is radical 2 over 2, minus, then over here, and I'm going to put this in here so we don't mess up any signs. The sine of 60 is radical 3 over 2, and sine of 45 is radical 2 over 2. So we have this. So now this is 1 times square root 2. We have radical 2 over 4 minus 3, square root 3 times square root 2 is square root 6. 2 times 2 on the bottom is 4. So here is our answer, square root 2 over 4 minus square root 6 over 4. And that would be acceptable, or we could put them together in one fraction since our denominators are the same, 4, as square root 2 minus the square root of 6 over 4. Now, you cannot, just as a reminder, you can't do anything more here because the square root 2, square root 6, they do not match what's under the radical, so you cannot go putting these two together to say anything crazy like negative square root 4. That is our answer. So that's one method that we could use these formulas when we're looking for the cosine, or we're going to look at the problem involving sine of some angle that we're not able to calculate, because not only are we dealing with coronavirus, we don't have calculators in this world. So if we can break them down into angles, we know we can use the formula to determine the cosine. Another way we can use this formula is going in what I think of as the opposite direction, where we're given a statement like this that looks suspiciously like one of our formulas up here. Here, 70 degrees, 40 degrees. These are not angles that we know, so we're not able to evaluate this without a calculator. However, if we were to combine 70 and 40, that might give us an angle that we can deal with. So let's take a look to see. We're looking at cos, sine, sine. So it's going to be one of these first two here. And because this is an addition, it's going to be this formula here. So this is the same as the cosine of alpha minus beta. So this formula here shows us the cosine of the subtraction of two angles. So let's identify our alpha and beta. So here, looking, alpha is 70 degrees, and then our beta is 40 degrees. So we've identified our alpha and beta, and now we can go back and instead of using the formula, if you will, we're going to go backwards to the original statement this formula represents, which is the cosine of alpha minus beta, the cosine of 70 degrees minus 40 degrees, which is the cosine of 30 degrees. 30 degrees, that's one of the angles that we know, and the cosine of 30 degrees is square root 3 over 2.